determine whether the intermediate value theorem implies that the given equation has a root on the given interval. In this case, we are working with a cubic function, x cubed minus 3x plus 9.1 equals to 0. Having a root means finding the solutions for x that make this cubic function equal to 0. And where they're asking, does it even make sense to keep looking on the interval from 0 to 1 or not? If I'm only told to use roots from 0 to 1 and they don't even exist there, it's handy to prove it through theorem first and ditch the whole problem and give the normal answer saying it's not there, choose another interval, rather than waste time in looking for it. Because imagine if this function is super complicated and you spend days and days of coding to solve for x when you could just prove using a theorem that there's no roots there. So why wasting the time? Especially imagine working with 5 or 6 dimensions at the same time, sometimes more than that. Anyway, the intermediate value theorem says that when the continuous function attains 2 values, it must attain all values in between those values because it's continuous, right? Basically imagine the function of your age at times 0 on the year where you were born. You were 0 years old, then 1 year later, 1 year old, 2 years old, 3 years old. It's a one-to-one function. It's a continuous function. The theorem says if at 0 your age was 0 and in 15 years your age is 15, then guess what? You had to go through all the ages between 0 and 15. There is no way that you jumped, say, from one point to the age 13, skipping the previous times. That makes sense because the function is continuous. So the function also should be continuous on the endpoints, which means in my cute example of age at 0 and 15. And then we say that there should lie at least 1 point on the inputs between 0 and 15, such that the output of that point is a finite number k. So let's talk about the example we have in front of us and why it has anything to do with the roots. Well, for example, the function has negative values as well. So imagine that we're asking what happened 10 years before you were born. Well, you were negative 10 years old. Let's say it's a makes sense thing to ask. I don't know. At negative 10, you were negative 10 years old. Well, if I know that the function was negative at first, and then the function became positive after that, and the function is continuous, it means it must have been going through 0. And 0 is called a root. So that is a handy way to prove if something has roots or not on the given interval. For our case, we're working with a cubic function. Cubic function looks like something like this: down, down, or up, down, up. Actually, in this case, I think it's going up first. Up, down, up. And they're looking at the roots. So here's the x-axis. These are roots of this function. It's supposed to have them. Well, they're asking if there are roots specifically from 0 to 1. And I don't know. If it's over here from 0 to 1, then we missed all the roots. If it's over here and it has 2 roots, and so on. So let's use the theorem to see if it's worth looking for those roots or not. Solution. Well, step 1, f of x, which is a cubic function, x cubed minus 3x plus 9.1, is continuous on closed interval from 0 to 1. Closed interval from 0 to 1. We can actually check that. It's a cubic function, right? So it's continuous everywhere. What is happening at 0 and what is happening at 1? At 0, it is 0 minus 0 plus 9.1, which is 9.1, which is positive. At 1, it is 1 minus 3 plus 9.1, which is 7.1, which is also positive. Well, that is not very interesting. We have that f of 0 is greater than f of 1, and they both are positive. Thus, we cannot claim that the function went through a 0, through a root, which means that we may be located somewhere here. We got value of 7.1. Well, it's going down here. We got value of 7.1 first. No, we got value 9.1 first at 0, and then 7.1 after that. And the theorem does not tell us that there is a root on the interval from 0 to 1. So the answer is no. The intermediate value theorem does not imply that there is a root. Answer: on the given interval, the intermediate value theorem does not imply that there is a number c on the given interval from 0 to 1 such that, as t means such that, f of c is 0, such that c is 0. Which means the theorem does not imply that this equation has a root. Root on 0, 1. Well, you know what? I wanted to show you, this is the end of this example. You can turn off the video and move on with your homework. But I wanted to show you when it will have a root. So note, if we keep the same function but change the interval, for example, from -10 to 1, let's check what is happening at -10. F of x is still continuous at -10, but what is that value of at -10? We will have -10 cubed minus 3 times -10 plus 9.1. That is -1 and 3 zeros, 1, 2, 3, so it's 1,000 plus 30 plus 9.1. I don't even have to know what value that is. I just need to say that it is negative. Well, you can see that the negative 1,000 is much larger than the other two numbers, two positive numbers. In this case, I definitely know that the function was negative, and then the function became positive at 1. And at 1, as we already calculated, it was 7.1. Since the function and the cubic function is continuous, since this function is continuous, it could not just jump through one point to another point without crossing the root. For this example, intermediate value theorem tells us that a root exists, and now we can use any kind of methods to find that root. So there is c that belongs on the new interval I've created, such that that number c gives me height 0. So this is input x equals c, and that is the root. I actually have a graph for you. Here's the cubic function we're working on. As you can see, from 0 to 1, indeed, both values are positive, and the intermediate value theorem says, yeah, I cannot tell you that there is a root there. But from -10 to 1, the function did go through 0 because it was negative at -10, and then it became positive at some point at 1. Thus, there should be a number c, which is somewhere -2.5. That is a root for this cubic function, which means at that c, the function x cubed minus 3x plus 9.1 is 0. I hope this clears up a little bit your understanding of intermediate value theorem.